Well, thank you for joining us for AI and Libraries. Tonight, we will learn how artificial intelligence holds the potential to revolutionize libraries and information work. I'm Greg Berry, Assistant Director in the UAB Office of Alumni Affairs. Since this is a virtual event, there may be slight glitches or things that seem out of place. If you experience any issues with audio or video, click the reconnect button at the top of your screen and you'll be returned to the webinar quickly and you shouldn't miss anything. Now, before we introduce tonight's guest speaker, I would like to ask a question. So let me go ahead and pull that up. We want to know how familiar you are with artificial intelligence. Maybe you're more familiar with American Idol than artificial intelligence, or perhaps you know a little, but you're working to learn more. Or maybe you're a pro and you know everything from inference to algorithms. I'm going to keep the poll up just for a little bit to get your answers. And it seems like this is heavy on the I know a little, but you're looking to know a little bit more. So after tonight's presentation, we will have time for questions. So be sure to place them in the chat box throughout the evening. I'm going to make sure that Dorothy has an opportunity to answer all of them. And here are the results of tonight's poll. Overwhelmingly, you know a little, but you're looking to learn more. We did have a couple people say they're more familiar with American Idol than they are artificial intelligence. So as we go ahead and introduce Dorothy, it is Dorothy Ogden. She is the head of Emerging Technology and System Developing at the University of Alabama at Birmingham Libraries. Her background is in academic health sciences librarianship, and she's a member of the Medical Library Association's Academy of Health Information Professionals. In 2018, she was a participant in the Data Science and Visualization Institute for Libraries. Dorothy is interested in applications of 3D printing, virtual reality, and the role of artificial intelligence in information discovery and research, teaching, and learning. At this time, I would like to turn things over to tonight's guest, Dorothy Ogden. Thank you so much for being here.
Thank you. All right, I think we're ready to get started. Thank you, everybody, for coming this evening. We're going to try and go about half an hour on this presentation, leaving plenty of time for questions, but I would invite you, as the session goes along, to put your questions in the chat box, and we'll definitely have time for some discussion at the end. I will just share my screen. There we go, and then we'll start the presentation. Okay, so AI and libraries. This is obviously a really exciting topic. We're going to have kind of three main themes that we'll talk about this evening. First, what do you need to know about artificial intelligence? And we're going to talk some about the ethics and the serious questions that are going on right now in the field in terms of how do we regulate this and use it appropriately? What are the implications of using AI in libraries? And then finally, some exciting examples of AI-enabled projects in libraries. So first, artificial intelligence. This is not a new idea. I have some examples here from TV and movies of artificial intelligence. You guys might be familiar if you've ever seen The Good Place. The first picture here is Janet, who's the virtual assistant. Janet is an AI. I know one of the devices in that show is that Janet often messes things up, and I think you'll see, if you think about it, that's a theme with artificial intelligence, both in the real world and in our fictional examples. HAL 9000 is the computer from 2001: A Space Odyssey. Spoiler alert if you haven't seen that movie. HAL gets some directions confused and ends up killing the crew he's supposed to protect because he's following a rule in his programming and he can't make inferences from it. Bender from Futurama is the cartoon robot. Again, Bender sometimes is out to destroy all humans. They use this for comedic effect. Bender's an example of an AI. He can autonomously make decisions based on previous data he's been given. And then the last example is from the Terminator movies. It's the robot, again, that goes back in time for some political reasons to assassinate someone before they're born. So there's a time travel story there. But it's also a story about an AI called Skynet, which is decided that humans need to be taken off of the Earth because they're a threat to its existence. So it's autonomously making decisions. And keep this in mind, how you might have seen artificial intelligence in media or television and what ideas you might have about it from seeing it in those places. You've probably already interacted with what we would call or would potentially fit under the umbrella of AI. So these are frequently called intelligent systems or bots. They've been around for a long time. You guys may recognize down here on the left, Clippy, who was a virtual assistant in the Microsoft Office suite for a while. He was not loved, but what Clippy would do was look at what you were doing in Microsoft Word or another application and then give you suggestions.
Dorothy, I'm going to interrupt you real quickly.
Yeah.
You have frozen, but more importantly, we can hear you, which is fantastic. But your presentation has frozen, so we can't see Clippy or anything like that. We're still stuck on the second slide about what you need to know about artificial intelligence.
Okay.
So I don't know if we can catch back up and get back on track with that, so we're not seeing that same slide. If we are, we can muddle through it.
Okay. How is this? Any better?
Same thing.
Okay, let's try starting the show over again.
And I can share those slides if I need to as well, if you want to go that route.
Okay. Okay, is that any better?
It is the same. Let me go ahead and call up the slides, and
all right.
You just tell me when to advance them, and I will advance them. So we should be seeing that first slide. And all right, there we go.
There we go. Okay. All right, sorry about that, guys. Just to quickly go back over this again, so just thinking about where we might have gotten ideas on what artificial intelligence is or how it behaves from movies and media, especially including the idea that artificial intelligence is malicious or it's not going to work the way it's intended. So again, we've got Janet from The Good Place, HAL 9000, Bender, and the Terminator. And then examples, I advanced the slides. Did you see that?
Yes, I did.
Okay, brilliant, thank you. Okay, so intelligent system you may already know and you've probably already interacted with. And I've got a couple examples here. One is actually the IBM Watson demo for a chat client for credit card payments. And you can see in that picture, if you can read the text, I tried this out. And as I was interacting with it, I also tried throwing it some words I thought it wouldn't know. So I said the word cupcake at one point, and it said, I don't know what that is, I'm sorry. So again, it's a system that knows how to look at what the inputs are and look at patterns, but it can only do that in a really narrow way. So if you throw it a word it's not expecting or that's not related to what it's supposed to be doing, it's not going to know what to do. There's another fairly famous example where on a lot of dating apps, there are bots, sometimes to people that aren't real, and the system will send you messages if you interact with them. Somewhere along the way, somebody found out on Tinder, sometimes if you get somebody you think is a bot, you can ask it to say potato, and it won't say potato back to you if it's an AI. So you can see there's a little snippet of text from an article there that gives an example of what happens when you try this with it, and it'll walk in circles around the word because it doesn't recognize it, it doesn't know what to do with it, so it doesn't have a response. So that system, while it's got some things programmed into it, can't make an inference or go, oh, that's a word I don't know, but it's doing the potato test, so I just say potato back, and the person will keep interacting with me. Again, just down here in the corner is Clippy. You guys might have also used Siri. Hey Google. In the very bottom corner, I actually have an example of, this is an intelligent agent called Dara that's built into our library's finding system. So on the back end of the system, the library is used to manage all of our ebooks, our books, our electronic journals, our print journals, our physical resources. We've got Dara, and Dara will pop up recommendations much like Clippy used to, and say things like, here are 7 records that match. Maybe you want to remove some of them or combine them so there are fewer records in the library system and it's more efficient. So again, taking in information that the system has been pre-programmed to recognize or look at and making a recommendation. And that's an older form of a system. Sometimes those used to be called expert systems. They are not necessarily AIs. And you'll find that, we'll talk about in a minute, it's really hard to define AI. It may not actually be necessary to define AI, because what you really need to look at is what is your tool supposed to be doing and how well can it give you the output that you need to get a job done. Just really quick to touch on this part, Lots of people have lost jobs in the pandemic, and there's typically lots of gloom and doom about AI. So in fiction, we have AI that frequently harms or causes the death of humans because somewhere along the way an algorithm's gone wrong or the computer's interpreted a rule in the wrong way. We also have this idea that AI is going to cause the end of all jobs for humans. It's going to replace people. You can see in some of the examples on this slide, the item in the upper left corner is a robot butler in a hotel. The item in the lower right corner is actually a robot that shelves books in a library, and that's from the National Library of Singapore. And then you can see some of those headlines as well about artificial intelligence taking jobs. And certainly this is going to change the work landscape dramatically in the next 20 years. It's not necessarily a reason for gloom and doom. A recent survey looked at 250 executives who were familiar with AI and asked how they thought it was going to affect their business plans and what they tried to do. And by far, more people think that it can be used to enhance features and performance of products, even performance of employees, rather than replace employees. So people aren't looking to replace employees as much as they are looking to improve the way their employees work using these tools. Similarly, you can see some quotes here. There was a famous supercomputer a couple years ago that beat Kasparov, the world chess grandmaster at chess. Well, then they started it on a game called Go, which is more complex than chess. It's a Chinese game. And they just built a computer. They instead of giving it previous human games of Go to analyze, they gave it the rules to Go and let it teach itself. And so that's been beating humans as well. And that used to be kind of a call for gloom and doom because now the computer is smarter than a human. When in fact computers are just really good at doing repetitive patterns and they can process that much faster than humans can. So a little bit of light at this tunnel, like don't forget that humans created the computer programs that can beat humans at this game. Meaning there is a place for us. It's not just a game of who can we replace with these tools to save on costs. And broadly, this is a video, I don't think it's going to work, unfortunately. What this is, I will send a link in the chat at the end of the session if you guys would like to watch this, and it'll also be available in the resources. But this is a video from a company called Boston Dynamics. It features 3 of the Boston Dynamics robots dancing to Do You Love Me? It's a fun video, but what we really want to think about with this is what does it actually mean to be intelligent? And there's a couple different ways to define this. There is a very famous researcher in this area named Alan Turing. You guys might know him from a movie that came out recently called The Imitation Game. Alan Turing came up with something called the Turing test, which was, he said a system could be considered intelligent once it could fool another human into thinking it was a human. But he also said defining intelligence in AI was really too meaningless to matter, meaning that it's an interesting thought problem, but it's not going to really get us anywhere to sit down and say, at this point, when we have something that can do this, then we will have created intelligence. Somebody named Larry Tesler, who was really famous in Silicon Valley and was a researcher at Xerox PARC, said at one point, AI is whatever machines haven't done yet. So when we think of AI, which means there's a constantly moving bar. First, intelligence was something that could beat another human at chess. Then it was something that could pass the Turing test. And now there are machines that have supposedly passed the Turing test. So now we're looking at robots and saying, what does it mean for a robot to be intelligent? Does that mean the robot can interact with its environment and change what it's doing without interference from a human? So can it make decisions about the world around it based on previous data like a human would? Does that mean it's intelligent? And in this video, you'll see the robots, they dance to the song and rhythm, they dance together, they don't run into each other so they can recognize each other. They can stand on one foot in balance, which took a really long time to program these to be able to do that. So they're showcasing very much what these robots can do, but also showing how the robots are able, without human interaction or human interference, to not fall over. To not run into each other, to be able to go backwards or forwards or balance on one foot. And so when we think about what intelligence means and what it means to potentially replace a human with an AI, the thing we should really be thinking about is what are humans good at versus what are robots and computational systems good at. Computers are really good at repetitive tasks. Humans are not good at repetitive tasks. We get bored, we get distracted, we get tired. Computers are amazingly good at repeatedly counting things accurately. Humans are not good at that at all. If we want to look at a bunch of things and make a judgment, humans have emotions. Again, humans get tired. If I want to look at 20 of an egg, let's say, and pick the best one out of that, a computer, once you've trained it, can do that the same way every time, whereas a human wouldn't. And so when we look at how that's going to fit into the workforce, that's the thing that looking at is what can we get an automated system to do that humans weren't efficient at anyway? And then how can we put those systems together with a human being in the workplace to improve productivity or to improve a task? And so pivoting from that, sorry, I'm on the wrong slide. Pivoting from that, what is artificial intelligence in the context of a library or an information corpus, right? Because unlike robots, as an example of an autonomous system, with books, we're not necessarily, or textual information or videos or recordings, we're not necessarily looking at how do I move this around efficiently or how do I do things that are physical more efficiently. We have a lot of information that's stored in some kind of format, whether that's digital or in print, or as a sound recording, or in some other kind of media. So within this, these are all words in this cloud that relate to artificial intelligence, so information retrieval, computer vision, classification of patterns. What we're really looking at today in libraries is a lot of use of machine learning for the most part, and there are some other things. But again, this gets really sticky to define because of what does it actually mean to have a machine that learns. You will hear, and I will talk about machine learning for most of the rest of the presentation today, but just keep in mind, people will use that interchangeably with artificial intelligence, and that's fine. People who really want to be sticklers about this, or if you're having a really interesting philosophical discussion, you can really get into the weeds on what's the difference between a true intelligence that can act on its own and make inferences on its own and go for new information on its own versus machine learning, which uses predetermined sets of data or a set of data it's gone through to then make inferences on its own. And so just to give you an example, these are all definitions of machine learning I've pulled from 3 different papers I used to prepare for this presentation, and you can see there are some similarities. So we're looking at AI, machine learning as a subset of AI. It uses algorithms to produce information about patterns and underlying trends in data. It uses statistical models to look at patterns. You can have supervised or unsupervised machine learning methods, and those are good for different uses. But there's not one exact definition for any of those things. So just keep in mind as we're learning a little bit more about this, you might hear it called machine learning, you might call it here AI. Machine learning is really more of what we're looking at for libraries, just because of the kind of information we're looking at. And then the overarching question with all of this is, we've had a huge explosion in the amount and type of information available in the last 20 to 25 years. And it's becoming really common to hear fantastical numbers in relation to how much data is available in the world. You can hear the word gigaflops, which is 1 billion floating point number operations per second, which is a lot. 2.5 quintillion bytes is a number that I heard. And a natural question that comes along with this is, we have so much stuff. How can the library build an AI to help me sort through all of this and tell me what to read? Or how can we use AI to sort everything out so I can make my work easier by having to look at a smaller subset of things? And I think that's incredibly complex. There is an overwhelming amount of information in the world, and it is difficult and time-consuming to sort through it. But a key piece of how we build information structures in our minds of how information fits together and how we synthesize knowledge and create new knowledge and new information is that process of digging through a lot of things. So that's not something we necessarily want to automate. What we want to do is create tools that will help support us in that, while not necessarily picking out what we're looking at or limiting what information we might access. And that's because one of the big dangers in AI is it's only as good as the information we put into it. So in your machine learning models, whether those are supervised or unsupervised, you're only going to get out what you put in. And the problem is everything we have to put in these systems is somehow flawed. Because humans are somehow flawed, because we have systems that are already built with systemic bias in them. And what we're going to do with AI, if we're not careful about that, is replicate that systemic bias. So this is an example. You guys might have heard of this experiment a couple years ago. Microsoft put a bot on Twitter. So they built a bot. It could tweet back to people. They designed it to sound like a teenage girl on Twitter. Her name was Ty. And then they designed it so as Ty interacted with people, it would tweet back. So it would kind of learn the culture, and it would interact with people in an appropriate way. But the problem was the culture they gave it was Twitter, and a group called 4chan got a hold of it and started feeding it very antisocial ideas, which it then picked up and repeated. So I think after a week, Microsoft shut Ty down, and then several months later put up another pot called Zoe, which had been reprogrammed so that if somebody started doing that again, it would kind of shut down the conversation and stop. And it's funny to hear about this because it was a well-intentioned experiment by Microsoft, but the lesson is frequently these systems, they're going to go in directions we might not have planned. Because of the nature of the information you're feeding it. You can see this is a comic called XKCD. This is about machine learning systems. And the joke here basically is you can pour data into something, and if you stir it around long enough with math, you'll get a pattern. And this is funny, but also there's a lot of truth to this because you can put any information into one of these systems, run an analysis, and get an answer. It's incredibly difficult to tell without testing if you've gotten the right answer. So one of the things to be careful about, and again, to be thinking about, is have you picked the right system for the kind of outcome you want? How will you test that outcome to make sure you're getting the results and the performance you want from your automated tool? This is from Kathy O'Neill. She's got a really great book out called Weapons of Math Destruction. She's a data scientist and a mathematician. She's got a really good TED Talk that's linked in the resources for this talk, and I'd encourage you guys to check that out. So she encourages people towards data skepticism. Her goal isn't to intimidate people away from AI, but what she wants to do is have us asking appropriate, informed questions, whether or not we've got a background in mathematics or computation. And she talks about in that talk news about racial profiling being baked into police facial recognition systems. And what happened in that case is the people that developed those systems said, oh, we used a standard set of images to train this data. Well, what they used was a set of images that had been scraped from early Flickr. And most of the faces in there were white because that's who the population of Flickr was at that time, whenever that image set was made many, many years ago. And the problem is there are not a lot of gold standard sets of data out there where people have gone through and made sure this is representative of the population. If you're looking at maybe a resume system, and she talks about this too, if you're looking at a place that has a culture where women have not been able to succeed, and then you take all the resumes from the people who were successful at that place and feed it into an algorithm and say, find more people that match this pattern who can be successful. You will build in a bias towards people who are not female. Because the algorithm can only look at the data you fed it and extrapolate a pattern from that. Again, most systems aren't true AIs. They can't look at things and go, oh, there's no women in this set. Maybe that's a problem. That's a job for a human, again, whether or not you have a technical background. So we want to, as we develop these tools, and this is a big concern in libraries, and I'm glad we're having this conversation, is talk about whether or not you're in that role. How are you asking questions about how your AI was built? How are you asking questions about how an algorithm was built and making judgments, and how you'll question the algorithm if you think there's a problem? So just some other things to think about before we dig a little deeper into the library piece of this. This is an article that came out last year, or 2 years ago now, about what happened when we switched to digital finding systems in libraries, because that switch happened really quickly. And so the author here is also not trying to scare people away from Google or Googling things, but just to talk about how there's been a shift in the way, because there's a shift in our information storage systems, there's also been a shift in how we've started to think. And he's certainly not saying that card catalogs were perfect. There's a lot of systemic flaws in those and in any classification system that's been invented for a library so far. They're definitely subject to the fallibility of human judgment and the ideas of what's right according to the academy, which we know can change over time. But what happened is that wasn't replaced with another classification scheme. It was just replaced with keyword searching. And so people will go and search and put in words into Google, find something, and keep going without necessarily doing a knowledge synthesis step. And you can see the quote from this article: digitization proceeded not by reproducing the knowledge that was in the card catalog, by vaporizing it. And so we've gotten into situations now. For example, there's a project going on at the University of Virginia. At the bottom of the slide, you see 2 photos of graduate students who found out the university was planning to throw out the rest of what remained of their print catalog, which hadn't been updated since, I think, 1987. And as they started looking at these card catalog cards, they realized that the front of the cards only had been digitized. Well, what happened is there were a lot of notes on the back that weren't necessarily standard to how the cards were formatted at that time, about and things like, somebody donated a book that was assigned first edition. Well, there's no way, as it turned out, the way electronic library records were standardized, there wasn't always information for that, so it didn't get captured. So in looking through this, these 2 graduate students said, we need to save this catalog because this is knowledge we might lose about the collection. And part of the reason this happened the way it did is because libraries were so quick to digitize and look at these standards without really thinking about, what does that mean for other systems that the library affects? So what does that mean in terms of how we make sense of bigger knowledge structures? Which leads us to preparing for machine learning in libraries. I've talked about bias, that if you do machine learning and you train something on a certain set of data, you've got to make sure the data is going to teach the system what you want it to learn. Which that's managing bias in a collection. We know all our library collections have bias. We know the way we previously classified items has a lot of bias, and there's definitely a lot of work being done in libraries now to correct for that, or allow for that, or expand what it means to have authoritative items in your collection, whether that's looking at who wrote a book, what a book is about, the format of something, to expand what information it is we direct people to, and make that more equitable and inclusive. All of that is about managing bias. So what we don't want to do is replicate the biases we already have in our current systems and build that into our next generation of tools. Planning how to address transparency and accountability. So as the library starts to build these systems, how can we address how we'll ask questions about how the system was built, how the system represents different type of information, and who that system should be accountable to. So who can ask questions about that, who can submit feedback about that for adjustments. Libraries, a big piece of what we do, and this is certainly a big piece of what we do at UAB libraries in the reference departments and instruction, is expanding information literacy to include fluency with machine learning and data science. So right now, our information literacy standards are a big piece of what libraries do to help combat misinformation and provide tools to students and really to anybody who wants to come to our courses or invite guest speakers to help them learn about, how do I tell if a piece of information is good or not? How do I evaluate how to find information and use it appropriately? And that's something we could expand to include machine learning and data science. So again, even people without technical or mathematical backgrounds have a basic set of questions that they can ask to help build transparency and accountability into those systems So as they become more frequent in the workplace and more frequent in our finding systems, we're able to use them appropriately, but also ask good questions to improve them. So we can hopefully try to avoid building as many biases or blind spots into them. Finding partnerships across campus and industry. You see the picture at the bottom of this slide is from a survey that was done in 2019, looking at libraries that had active AI or machine learning programs. The number is actually pretty small, although it's growing, and certainly the projects that are out there are really exciting. And one of the recommendations from that survey is for libraries to go and find partnerships on their campuses, and that's definitely something I'm excited about, and we've been talking about in UAB Libraries and the Technology and Technical Services Department, is how do we build those partnerships, again, to create useful tools. So not necessarily saying, let's build an AI and figure out what it's good for, but say things like, maybe we've got a collection we haven't really gone through yet, and we'll talk about a way to do that in a minute. Since we don't have enough staff to look at each individual digital picture, for example, how might we be able to use machine learning to process that and to make it more accessible? And then finally, creating machine actionable collections, and that's a really big emerging area as well. What that means is formatting your collections and your data so that you can easily put it into one of these machine learning tools. Right now, a lot of library cataloging records are standardized so a computer can read them, but they're not necessarily standardized so that they could be easily read or crawled by a machine learning algorithm or a text bot. So building out collections that way and building that in, so as we get ready to analyze these collections or make them more accessible using these tools, it's a lot easier to put the data in and then to put it in the future for different projects. So transitioning now to sub-examples from libraries, which is the most exciting part of this. First thing, the University of Oklahoma Libraries has created a projects in an artificial intelligence registry. And you can go to this website. It is open to the public. If you're looking for a directory of AI projects in higher education, they've got a lot of examples here. You can also register projects as well. And I know in libraries and higher education, there's a big push to make sure most of these projects are open source and available, which means you can replicate them as they're done. And so some of the projects I'm going to show you today, they are open source. If there was staff time and resources available, anybody could replicate them at their institutions, which is, again, good because we can both replicate those projects, but then also ask those transparency questions and accountability questions. So as a project is implemented, look at that code and say, oh, is this doing what we think it does? How can we develop good questions about this? How might we improve this tool if we discover that the output isn't what we expected? This is an example from the Broward Public Library System in Florida. Unfortunately, it's a video. It's not going to play, unfortunately, but I would encourage you to go check that out if you get the link from the resources. The librarian in this video is Bob Anstet. He's done a fantastic job in the last few years bringing a lot of emerging technologies into the public library system in Broward County. He recently led an initiative to deploy voice assistants, and so those are some of the virtual assistants I showed you earlier. They're using Amazon Echo Dots at all of their library information service branches. And what you would have seen in this video is Bob uses the dot to translate an interaction with the patron who's come up to the desk. So a woman's come to the desk, she speaks to him in Spanish. He doesn't know Spanish, but they have the translation module turned on for this. And Bob's done a lot to build out what might be called a skill for these virtual assistants. So building out the computer code that allows the assistant to go do something like search their specific library catalogs. It doesn't necessarily happen automatically. It is something that libraries can build into code and then upload to the database and link to the dot to give it the specific function for that specific library. So in this interaction, he's able to translate and help her check out a book, even though he doesn't know Spanish, using that tool. And the Broward counties aren't the only libraries doing this. I know the University of Iowa Libraries have also built a set of Alexa skills for their libraries discovery system, which is called InfoHawk. And they have a page that's, again, linked in the resources you have from this presentation. And that tells users what they can do. So students can do things like ask Alexa, what are the textbooks on reserve for my course? how do I find materials for my course, things of that nature. And there has the number one concern with all of these things in developing the virtual assistants for libraries has been user privacy. So in developing InfoHawk, I know the university libraries at Iowa didn't want to do anything that would reveal student information, and so they built that into their system to be mindful of that. Same thing with the Broward Public Library. All of those skills don't reveal any user information to the Amazon systems, and Bob was able to build that in without a problem as he developed those skills. This is an example from a company called UNO. They are a knowledge engine, and so what you'll see here is there's what's called a knowledge graph, and so this is creating a visual representation of the relationships the system has found between different pieces of information. And if you look at the side, so this is an example from their website. It shows artificial intelligence, and you can see in this, it's linking artificial intelligence to kittens. And I couldn't tell you why that is at the start, but what they're doing is visually representing the linkages in that knowledge. And what that does, you remember we talked earlier about how it's not maybe a good idea to say, build an AI that will tell you, read this, don't read this, this is high quality, this is not high quality. But with a product like what you can do is look at those relationships pretty easily between concepts. So it might have taken you, if you were using the kind of retrieval and discovery systems we have now in the library, a while to scroll through enough results to figure out the system had retrieved both a paper on artificial intelligence and a paper on kittens. But with this type of browser, you can see that automatically, and so it will expedite how you explore information, and again, how we build those knowledge structures in a way that's similar to what we might have been able to do in the old card catalog, but obviously much more quick and much easier to interact with. And you can see on the side where it's pulling the definitions from, that it made these judgments about how related the words were. That's what you see in the knowledge graph. So things that line distance is a symbol of how similar the system thinks these terms are, and that's how it figures out how to space them out in this visualization. And you can see UNOW uses the medical subject headings, which is published by the National Library of Medicine in the PubMed database, and then also this is taken in some information from Britannica Academic. So pulling things in, doing some machine learning, and some math on the words to provide this visualization and way to explore a corpus. Robots reading Vogue is one of my favorite examples of machine learning. This is from the Yale Digital Humanities Lab. What I like about this, there's a lot of things I like about this project, but one of the reasons I think it's so interesting is what they were able to do is go through and kind of average all of the images of Vogue covers throughout time. So they have the complete digital archive of Vogue and all of the covers. So they were able to build a lot of different tools. This isn't the only one. I'd really encourage you to go check out this site if you're interested, to do things like analyze the colors that were used in all of the Vogue covers. So things we really could not have done easily before we had access to these tools. And my favorite thing about this project is one of the things they did when they averaged the covers is this is a decade of Vogue, each per image. And you can see from this analysis they've done, they figured out Vogue design got into a real rut for 2 decades. So even though this is 10 years of cover items, trying to draw on that. It may not work. Okay, here we go. So you can see features like the eyes of all of these images are almost in the same place, such that you see really clear eyes or really clear facial features on these pictures as opposed to the ones on the bottom, which are more abstract and kind of difficult to make sense out of. So that might tell us something interesting about what was going on at Vogue at the time, what the current thinking was about what's attractive or what might sell a magazine versus what Vogue was publishing earlier in previous decades. I wanted to show you really quickly the Library of Congress Labs. They're doing a lot of really interesting work. Lately, they are part of the Library of Congress's new digital initiatives to connect all librarians to the library and make those digital collections more accessible. There's a lot of really neat projects here as well. One thing they're doing is exploring machine learning in their cultural heritage collections. So they're doing a lot of the experimental work, looking at different kinds of machine learning, how you can apply that to different collections that are already digitized at the Library of Congress, and ultimately, how can you make those collections more accessible to the public by using these tools. They also have a lot of really cool projects. There's a lot of really interesting stuff to explore on their website. A project I wanted to share with you this evening is called Newspaper Navigator. And so this is actually still a pilot project, but it is available publicly if you want to go take a look at it. And the Library of Congress has a database called Chronicling America that has over 1.56 million images digitized out of newspapers, and that's hundreds of years of newspapers. And newspaper search, as we know it right now, might not seem that exciting because we're used to going and putting in keywords and getting things back. But what's interesting about this is it will search for image similarity rather than searching for textual content. What that means for libraries on a practical level is you could ingest all of these images and run some of the AI tools and come up with ways for people to explore the collection without a human having to look at each explicit image and enter specific information about it. Because if you think about having a human library employee look at 1.6 million images would take lifetimes. There's not enough time to do that. And then to have that person describe and classify that image so that a machine could read associated text is not possible. But what we can do is, with these tools, is put collections in and then give new ways to interact with them. So what I'm doing here, I decided to look for coats after watching the inauguration yesterday. I got a lot of images of coats, but you can see there are also people in dresses, things like that. I was able to quickly train an AI navigator by picking images I wanted it to find similar images for. So this is in real time. It will go through, analyze the information in the individual pictures and find similar pictures by doing things like comparing the color values in the picture, in the pixels in the picture. So you can see I trained my navigator. This was my search result. And then you can compare how my search results changed once I applied that navigator. Okay, so that one's a really exciting project. Again, go and check all of those out. The implications for us, again, in libraries, and particularly at UAB, is as we have more digital collections coming, and interact with them, not just limited to text matching or keyword searching. So wrapping up, talking about AI fact and fiction, and I've got some examples for you again of AI in fact and fiction. Two of these examples are things that are happening right now. One on the left is a robot nurse that's being developed in Japan to help lift patients. On the other side of that slide, you'll see something from the Wolfram Alpha knowledge engine. I looked up artificial intelligence in libraries. The Wolfram Alpha engine, rather than being a search engine like Google is, where you put in terms and it matches and then does some ranking according to the behavior of other people, is it tries to make those linkages for you. So thinking about what we talked about in the beginning of this presentation in terms of machines being able to make inferences and find similarities. So it's doing that and putting the information together in a different way. That's also available freely right now online if you want to try that out and see what the difference is between that and something like Google. The two examples from fiction are Knight Rider. Kit from Knight Rider, which was a car that could drive itself and also talk to the main character of the show, and then an android from Star Trek, who again is able to make judgments and alter its programming based on what's going on in the environment around it. So lots of this is moving from fact to fiction. Even so, it's not going to hopefully have some of the negative connotations once it gets here the way it does in fiction. These technologies hold a lot of promise and a lot of peril. It's really easy to create an AI or bot, as I've showed you, or a machine learning tool. And as we talked about when we looked at the XKCD comic, you can put any set of numbers into a model and generate a result. You get into trouble when you don't necessarily know how to ask the correct questions about the conclusion that you got out of the tool. So when you don't know how to analyze, or you aren't choosing to ask questions about whether the results you're getting are usable results and they're giving you the information you need. So it's easy to create bad AI, and it's easy to create bad algorithms. We don't know how to dependably create machine learning and AI-based tools that won't have baked into them the difficult problems that are inherent in our current systems, such as racial or gender bias. This doesn't mean don't use these tools. It just shows that we all need to have some level of literacy with these tools as we go forward, whether our backgrounds are in computer science, humanities, mechatronics, or librarianship, so we can understand the strengths and weaknesses of what's going on and ask effective questions, which lead to informed conversations about how we should govern these tools, how and when they should be used, and how they'll fit into the grander tapestry of our lives. So I'd like to encourage you guys today to go out and learn more about AI on your own. I've on the wrong slide again, sorry. I've got some resources for you, and those links will be available as well. These are all non-technical courses that are freely available online, with the exception of Kaggle at the bottom. That is a data science heavy application, but if you have heard this talk and feel inspired and want to go and try and do some machine learning on your own, Kaggle has some great tutorials there for building models. I've played around some with their real estate data set. For the other three of these, freely available. You don't have to have a technical background. They will start you from no information at all to learning about pros and cons, again, how biases get built into systems, things to be aware of, and questions to ask when somebody maybe brings you a tool and says, here's your AI, go. So that you are having those conversations and we are supporting having transparency in these tools and looking at critically at how they're applied. With those things, please, I encourage you stay enthusiastic, be open to learning about these, and be open to asking questions. It's going to be very important to evaluate and reevaluate these tools as they evolve. With that slide with the example bots, I know a lot of those, when you use Siri or Google, sometimes it's really clunky and it doesn't do what you want to do, but it is going to improve. And that'll be where that reevaluation piece comes in. This is my contact information, and I think this will be available after the talk. So I would encourage you, if you have other questions, please reach out or visit our website. That was all I had for today. There are some resource links. These are not the prettiest slides here at the back, so just be aware. Those are there for you if you wanted to learn more about anything that I showed in the presentation today. And again, I'm happy to chat with you about that. Thank you very much for your time, and I think we're ready for questions.
Exactly. And just so everybody does know, in the File tab down at the bottom of your chat, the document that Dorothy shared earlier with us is in that section of the chat. It's called Resources for Learning About AI. You can go ahead and download that and have more of those resources. So let's go ahead and get to the questions right away. Is AI capable of learning how much people fear it because of its power? And could it figure out a way to prevent the control, the creator from removing its software?
To my knowledge, and now I'm not at IBM, or I'm not at Google, and I'm not at one of the big tech companies, but to my knowledge, no. So that's where we talk about what is true intelligence. So that self-awareness is part of what we talk about sometimes when we say, is this AI really intelligent the way a person is intelligent? Or is it just a really complex system? So to my knowledge, no. Right now, and I could be wrong, there's not a system out there that you could do that with. That doesn't mean we're not capable of building one. But for now, no.
So how much should people fear AI, or should they fear it at all?
So I don't think that we should fear it. I know that's what we get a lot when our example is the Terminator or it's Janet, that AI is going to be used to replace you and you're going to be out of luck. But what you'll see more is usually an automated system replacing something that was really repetitive anyway, and opportunities for retraining. I think the thing we need to be open to is taking those retraining opportunities. Because more than likely, these systems are really complex. They're hard to build. Sometimes when a business says, yeah, let's get an AI and replace all these people because they won't get tired, this or that, like there are different costs there. It's not that the AI doesn't cost money. It's that the costs are different for the business. And so we'll see those average out over time in different ways. And I think we'll see jobs where humans are preferred just because it's easier to put a human there than it is to program an AI or an autonomous system to do the same job. So we shouldn't be afraid of it. It's going to enhance our work, I think, by and large, more than it's going to replace us. But I think we also need to be aware that change does happen and to be ready to take those opportunities to retrain or learn a new skill when they come up.
In what ways do you think AI will change the process of searching for something using a search engine?
I think over time we're going to see more tools like YouNow. And YouNow, I have seen, I'm really excited about that. I look forward to the day that's widely available, keeping in mind that I finished my library degree closer to 15 years ago. We're not quite part of that. And the idea of drawing vectors and graphical representations of the way concepts are related was old then. It just hasn't been popularized yet, but I think we'll see more things like that, where it's not the system telling you, yes, no, read this, I've evaluated this and it's good and this and it's bad, but more, here's how these concepts are linked together, here's how this information goes together, here's a guide to how to explore this in a way that's not so flat as the way we know it now, which is kind of a, I'll put a term in, I'll get some things out, maybe that's what I want, maybe not, I'll go back in. Because keep in mind, with the search engines we have now, a big piece of how those work, and they're not bad, they're really interesting systems. It's just we're about to have the capability to do things that are more complex in terms of how the concepts are related and the machines kind of linking those together and making those judgments and giving us a tool that we can still explore and say, oh, these concepts are linked, I want to go look at that. That concept I'm not as interested in, but it's good to know it's out there and it might be associated. Or, boy, it's sure weird that artificial intelligence and kittens are linked together on this graph. Let me go see why the machine might be pulling kittens out.
Working in the libraries, you probably deal with a whole bunch of different formats. What OCR technology do you use for the scan documents, and how do you deal with misspellings?
So we don't have that set up yet in UAB libraries. I've been exploring Pandas some. I would think we'll end up with something really similar to what you have in a controlled vocabulary. That's what a controlled vocabulary does in the first place, right? Is it allows for variations in spelling and some support for synonymy. And so that same tool, I think, would apply there as well. Just, again, building that out. And that's where we talk about strategic planning and building that into our systems, is building that functionality in as well.
When it comes to search engines, is there a better one or a best one when it comes to AI?
I don't think so. I would say go check out the Wolfram engine, because it's really interesting what they've tried to do there. Because again, it's not a flat system of, I put some terms in and I get back the terms that are the results that are most relevant based on what other people have done. It's approaching that in a different way in terms of linking what concepts are and the results it gives you to explore.
This one might make you think a little bit. If your resources and time were unlimited, what AI project would you like to undertake for the UAB libraries?
So I really want to try, and I hope I don't get in trouble for this one, some of the projects they've done at the Yale Digital Humanities Lab. So they have another project, and it was in beta. I happened to see it at a conference. I'm not sure that it's released yet. That was kind of a knowledge graph, but for pictures. So similar to what we saw in YouNow, you could put collections of images in, so like we saw at the Newspaper Explorer, and it would give you an analysis of the things in those images. And it was doing pretty basic things like buttons and hats and faces. But then you could also scale it on a timeline. So you could do something like, I'd like to see all of the pictures with buttons from the year 1900. And you can see how that would be really interesting to dig into if you could do something like, here's a collection of images from Birmingham, and it's all of the same street. There's a related project that I believe Stanford and the Yale Digital Humanities Lab are collaborating on, called Every Pixel on the Sunset Strip. And they're taking different collections of images of things on the Sunset Strip, so the same stretch of road over time, and then using those images to do analysis of what appeared on that road over time. So you can do things like look at how long a certain model of car was visible, and maybe look at how long people were driving a certain model of car in a certain region, for example. So projects like that, I think, are really interesting. There's lots of really good stuff going on in this area. It's hard to pick just one, but those are two I'd definitely be interested in digging into, given unlimited time and resources.
How much regulation is there over AI, if there is any? Should there be? And is it even possible?
So not a lot yet. That's why a lot of these conversations and a lot of people in the industry are saying we need to have these conversations now, including if you go and look, that Wolfram engine I showed you, one of the people responsible for the company that builds that is named Stephen Wolfram. And he and some of his colleagues testified before Congress, I think 2 years ago, about how they don't even know what some of that code does. And they're the people that came up with it. They built up the industry. They don't know what it does, and there's not any regulation of it yet, and they think there should be. So they've gone out and said, we need to be looking more closely at that, and that's why you'll hear it as you start to look at this and talk to people, whether those are sociologists or people in the industry, going, we don't need to have unfettered black box algorithms. We need to know what's going on in there in some level and how the algorithm's been designed to make decisions so that we can say whether or not we're getting what we meant to out of that. The speaker that I mentioned who wrote the book Weapons of Math Destruction calls this interrogating the algorithm. So she talks a lot about an industry right now. You might get a product and it says, oh, I have AI built in. And you might say, okay, well, what's the AI? What's the algorithm? And they'll say, oh, no, it's secret sauce. That's an industry secret. We can't share that. But then it will be used. The example she gives is in the New York public schools. It was being used to make hiring and firing decisions about teachers based on algorithm results, which hadn't been in the talk that she has, and it's linked in your resources there. She shows it really wasn't, if you tested the output, something that looked very rigorous, but people couldn't appeal it the way it had been adopted by those schools. So there's not a lot of regulation right now. That's why if you've heard about police departments implementing and then stopping using facial recognition software, that's why, because there's not necessarily a standard in place to say, here's your facial recognition software, here's the way you can apply it, here's the way you can use the results of it, let's say in a court, or to go arrest somebody. So that means probably different standards are being applied in different ways. So it's a conversation we need to be having right now before we have more tools that are built that aren't meeting a certain standard or a certain ethical practice.
Well, this has been very informative, great information that you have supplied us tonight. And your video did freeze, so we are seeing a black screen, but we heard everything, we saw the presentation. So again, thank you so much for taking the time to be with us tonight, Dorothy.
Thank you very much. Thank you, everybody, for coming. I'm glad you found the session informative. And again, please let me know if you have follow-up questions.
Awesome. Well, just a heads up for everybody that is online tonight, a recording of the webinar will be available on our website tomorrow. Be sure to join us for some other virtual events. We'll be getting interactive on February 4th as we host This Body Doesn't Do Yoga. Then February 18th, find out how we can improve our health literacy game during Health Literacy, finding information you can trust. And on March 4th, we'll be joined by Dr. Holly Wyatt for How Can You Achieve Lifestyle Wellness, a webinar that reveals a never-before-seen initiative from the Department of Nutrition Sciences. And finally, on April 6th, take part in UAB's Oral History, another special from the UAB Libraries. So it's the UAB's Oral History Collection as we explore more about the history of UAB, Birmingham, and Alabama. You can register for all of our events and see other upcoming events, virtual or in person, once they come about at alumni.uab.edu/events. Need a podcast to listen to throughout your day? Listen in on UAB Green and Told. New episodes are released every other week with conversations from members of the UAB community. Find and subscribe to our podcast on Spotify and iTunes, or visit alumni.uab.edu/green and told. Be sure to stay on top of all things alumni on social media. We can be found at UAB Alumni on Facebook, Instagram, and Twitter. And look us up on LinkedIn by searching UAB Career Community. Finally, if you want more information about the National Alumni Society, visit us at alumni.uab.edu or email alumni@uab.edu. Once again, thank you so much for joining us. Thank Dorothy for her great presentation. Have a great evening, and as always, go Blazers.